This is evident as when we solved 5 squared times 5 cubed, we got our answer to be 5 to the 5th power. So we can see where the base remains the same, but then 2 plus 3 gives 5 for the power. And in 7 squared times 4 to the 4th power, we are unable to combine the indices since the bases are the same, so it will remain 7 squared times 4 to the 4th power. In these examples, we will learn to evaluate index or exponential expressions that involve division. So in our first question, we have 5 to the 5th power divided by 5 squared. We know that division can also be represented by placing it in fraction form to give 5 to the 5th power divided by 5 squared. We can now go ahead and write our expression in expanded form to give 5 times 5 times 5 times 5 times 5 divided by 5 squared, which is 5 times 5. Now, similarly to when we are simplifying a fraction, we can simplify this fractional expression of the exponential numbers by finding the highest common number, the highest common multiple of the numerator and denominator, and dividing the numerator and the denominator by that multiple. So the highest common factor being 5, we'll see 5 divided by 5 is 1, 5 divided by 5 is 1, 5 divided by 5 again is 1, and 5 divided by 5 is 1. So in our numerator, we'll be left with 5 times 5 times 5, all upon 1 times 1. So that would be 5 times 5 times 5 in index form is 5 cubed, and it is upon 1 or 5 cubed. We could also work out the solution to 5 times 5 times 5 on our calculator, where we will see that 5 times 5 equals 125. In our second example, we have 4 to the 7th power being divided by 4 cubed. Again, we will start by writing the exponential values in fraction form, so that will give 4 to the 7th power over 4 cubed. 4 to the 7th power in expanded form is 4 times itself 7 times, That's 4 times 4 times 4 times 4 times 4 times 4 times 4. And that's all upon 4 times 4 times 4. Four into 4 goes one time. 4 into 4, 1. 4 into 4, 1. 4 into 4, 1. It should be numerator, denominator, numerator, denominator. So in our numerator, we're left with 4 times 4 times 4 times 4, all upon 1. In index form, 4 times 4 times 4 times 4 is 4 to the 4th power. And if we are to solve by punching in on our calculator, we'd get 4 times 4 times 4 times 4, which is 256. Here we will notice that when we solved 5 squared divided by, 5 to the 5th power divided by 5 squared, we got 5 cubed. The base remained the same. However, we can see that 5 minus 2 would give 3. Here we had 5 to the 7th power divided by 5 we had 4 to the 7th power divided by 4 cubed to give 4 to the 4th power. So we can see again the base remained the same and the powers were subtracted. From that, we can draw the conclusion that when dividing exponential numbers of the same base, of course, the base remains the same and the powers are subtracted. This brings us to the end of this video. In our next video, we will look at negative powers. See you then.